Alright, hello guys, and welcome to the first day of Trig. For this lesson, we will be using our calculator. I'm currently using for this video a TI-30. In a later page in your packet, you'll see the instructions for a TI-84. If you want to use Desmos, go for it. I'm going to use my TI-30 because I can't use Desmos while on this video. So, we're going to get started with Trig, and the first thing is vocab. I know you'll love this. Let's get started. So, first thing to talk about with trig is what the heck even is it? Alright, trig. Break it down. Trigonometry. Alright? Trigo, actually. It's not tri, it's trigo. Tri is 3. Trigo is three-sided figure. What three-sided figure do we know of? The triangle. So, trigonometry quite literally is the study of triangles. Alright, and what kind of triangles, you may ask? I'm glad you asked. Right triangles, specifically. Okay, now we'll learn a little bit later on in this chapter about the law of sine and cosine, which will allow us to address other types of triangles. But for right now, we are focusing on right triangles. Now, other vocab words to be aware of is something called a trig ratio. Alright, a trig ratio is the ratio of the lengths of two sides of a right triangle. Okay. Two sides of a triangle, of a right. Okay, so first and foremost, if you are ever asked for a trig ratio, I'm going to ask you for a literal ratio. I want a fraction. Okay, so bear that in mind. Whenever we're doing trig ratios, it's going to be fractions. Now, we're going to be using those ratios to solve for things, but everything starts off with that fraction. Now, hopefully these next three words are not foreign to you, especially that first one. But let's go ahead and define them anyway, because these are terms we're going to use for the rest of the chapter, and you have to know what they mean. Okay, so all of these, hypotenuse, adjacent, opposite, all of these are in, I'm going to do this in red so you can tell, relation to the angle. Which angle? Excellent question. That's why this is so important. The angle changes. Now, the hypotenuse is the only steady one. It is the side opposite. Actually, I'm going to change words here. Okay, side across from the right angle. Okay, so in a right triangle, the hypotenuse is always going to be across from the right angle. That will never change. Opposite and adjacent is where things get fun. The opposite side is the side across from the angle. Okay, and I'm going to, the angle. And the adjacent side is the side next to. Oops. Next to or touching. Okay? So it is either one next to it or it's touching it. Can't spell today, guys. It's okay, though. Okay? Next to the angle. Now, what does this even mean? I'm glad you asked. Let's look. Okay? When I'm talking about the angle, I'm referring to the angle that we are using in the problem. Now, we have two symbols right here. This one, and this one. This symbol right here is the one we'll use a lot. It is a Greek letter theta. Okay, you'll hear me say theta all the time in this PowerPoint. Theta is the main angle that we're looking at. This angle is called alpha. Okay, we use Greek letters to refer to the angles so that you don't get them confused with the side lengths. Okay, so when I'm trying to identify things, I'm going to identify them in relation to the angle that I'm looking at. The hypotenuse will always stay the same. That's going to be D. But pay attention to the instructions. I want the side opposite of theta. Well, opposite of theta is B. And the side adjacent to theta Well, that's C. Okay? But when I erase all of this and go to do alpha, okay, I'll change colors. The side opposite of alpha is C. And the side adjacent to alpha is B. Okay? So it's really important in these to pay attention to which angle you're dealing with, because that will change which side length you're addressing. So, try it out for yourself. You guys go ahead and do the other 3. Make sure you pay very close attention to where you're starting from and to the instructions. The video will pause. When it plays again, you'll see the answers. And here they are. How'd you do? So, 2 things I want you to know before we move on. Number 1, the hypotenuse is itself. Notice how the hypotenuse is never classified as an adjacent side or an opposite side. It will never be so. It is the hypotenuse. It is its own category. Number 2, notice the flipping pattern going on here. Okay, trig is full of patterns. You need to pay attention to these patterns and how these things relate to each other, because that's going to help you further on. Let's keep going. All right, now we are down to the infamous sine, cosine, and tangents. So let's start off with defining them. Now, first off, I'm going to use this triangle over here, and I'm going to use theta, since that's what they give us. So the first thing I'm going to do is I'm going to define and label my triangle. I'm going to say the hypotenuse over here. This is the side opposite of theta, and this is the side, I don't like that, let's fix that. This is the side adjacent. Oh well, adjacent to theta. Okay, so there's my triangle, and I'll be using theta in all these definitions. So let's start with sine. Sine is the ratio of the length of the opposite side over the hypotenuse. Okay? So the opposite side over the hypotenuse is going to look something like this. Opposite over hypotenuse. Now as for the notation, this is going to be the sine of theta. Sine of theta. We're going to be using this language of to describe all of these things, because the sine, the cosine, the tangent, they are all functions. They do things. Just like you have f of x or g of x, you're going to have the sine of theta, this cosine of theta. These are all functions. Now the way it's going to be pronounced is going to look / sound something like this. And that's how you say it. Now cosine is the ratio of the lengths of the, I'm not going to write all that again, adjacent side over the hypotenuse. So again, you have a side over the hypotenuse. And its ratio looks like this. Adjacent over hypotenuse. Its notation is just COS. So cos. But you say it like cosine of theta. All right. Last but not least, we have tangent. And tangent is the opposite side over the adjacent side. It is the only one that does not have the hypotenuse in it, which when you're doing problems is a good way to recognize it. If there's no hypotenuse, then it has to be tangent. Okay? You're going to say it at, the notation is TAN. So tangent of theta. And that's about exactly how it sounds. Tangent of theta. Now, there are, yes. All right. There are other trig functions. These are called the cosecant, the secant, and the cotangent. And they are the reciprocals of our main 3. Together, they make up the 6 trig functions. So the reciprocal, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And then tangent is the reciprocal, or cotangent is the reciprocal of tangent. It's kind of the only obvious one here. Their symbols look like this. So again, cotangent's kind of the only obvious one here. But we're really not going to deal with these. Cosecant, secant, and tangent, they show up in Algebra 2. So something to look forward to. I just want you to know, you'll see them again later. But for right now, the only ones we're dealing with is sine, cosine, and tangent. Now, so far, there's a lot of information going on, which is why there is this fun and fancy acronym. SOHCAHTOA, to help you remember all the information. Now, the acronym quite literally spells out the information as you need it. The sine of theta is equal to the opposite side over the hypotenuse. The cosine of theta is equal to the adjacent side over the hypotenuse. And the tangent side, or tangent of theta, is equal to the opposite over the adjacent. If you can remember this acronym, you literally remember the order of the information and what bit goes with which function. So let's practice. Using SOHCAHTOA, we're going to do the trig functions for all of the angles. Well, I say all, there's only two. So for both angles. Notice we will never do the trig function of 90. It's not going to happen. Okay, 90 does weird things. So it's only ever going to be theta or alpha. I'm going to make this one theta, and I'll make this one alpha. Now, we want the trigonometric ratio. I want you to read fraction. Okay? All I want is the fraction. That's it. I want sine of theta equals fraction. That's it. So here we go. Start off with sine. This is opposite over the hypotenuse. So that's going to be b over d. Next is cosine, which is going to be the adjacent over the hypotenuse. The adjacent is right next to it, so that's going to be c over d. And last but not least, the tangent of theta is equal to the opposite over the adjacent, so it's going to be b over z. Your turn. Do alpha. And here are the answers. Notice again that the fractions flipped. Okay? So you always want to make sure that you are picking the right angle and using the correct orientation from that angle. It will change your answer. The sine of theta is not the same as the sine of alpha. Let's move on. All right, let's do some problems with these ratios. Now on this page, if you notice, you have the 4 triangles, but you are missing side lengths for each. Okay, we'll get to a point in the PowerPoint where you use trig to solve for the side length, but for right now, I want you to use Pythagorean theorem to solve for the side length. The main focus of this page is to set up the ratios. We're still getting used to these ratios. Knowing the orientation of the sides is one of the key things here. So let's do this first one. Now, if you remember last lesson, you will remember that this 512 is a Pythagorean triple, which means that I know that x is 13. Now, if you didn't remember your Pythagorean triples, you can just do Pythagorean theorem. I'll set it up for you, but I'm not going to do it. And you can solve for what x is. I remember my Pythagorean triples, so x is 13. Ba, ba, ba. Okay, I'm going to do theta. You're going to do alpha. So, in this case, the sine of theta is opposite over hypotenuse. So, that's going to be 12 over 13. Cosine of theta is adjacent over hypotenuse. So, that's 5 over 13. Tangent of theta is opposite over adjacent, and that's going to be 12 over 5. you guys do alpha. Okay, how'd you do? Hopefully you did well. What you're going to do now is you're going to do the rest of these problems. So use Pythagorean theorem or your Pythagorean triples to solve for x, the missing side, and then set up your ratios. Make sure you reduce the ratios. Now this first problem didn't have any, but over here in the second problem, you've got 16 and 20. Okay, I just know by looking at it that if those two are in a fraction, they're going to reduce by 4 at the very least. Okay, so whenever you have a ratio, rules of fractions still apply. Make sure you reduce it. Good luck. Okay, here are your answers. How'd you do? So hopefully the first one was fairly easy, or correction, number 2 is fairly easy. I'm going to zoom in on this one. So if you noticed, I don't know if you did or not, if you did Pythagorean theorem, that's fine, but I want to point out the pattern of the Pythagorean triple. You have 12, 16, and 20. As I mentioned earlier, 16 and 20 reduced by 4. All right, that should have gotten you thinking, maybe the other side has a 4 in it as well. A 12, 16, 20 triangle is also a 3, 4, 5 triangle. It's one of those multiples, which means it's a triple. If you didn't see it, that's fine. I don't expect you to. But as you're doing these problems, make sure you're staying on the lookout for your Pythagorean triples. All right, problems number 3 and 4 were where things got interesting. Now, first off, you had to do Pythagorean theorem because these were not triples. So check out those answers. Make sure that you at least got x correct. Because then we get into simplifying our trigonometric ratios. Focusing on 3, remember, you cannot leave a radical in the denominator. So for sine of theta, you would have had to have, I'll do this one off to the side, so you have 6 over 3 root 13. Why is it that big? All right, let's zoom in. Let's see if that fixes things. Much better. 6 over 3 root 13. So I'm going to multiply the top and the bottom by the square root of 13. That way I can cancel out my denominator. It goes away. I have 6 root 13 in my numerator, and I have 3 times 13 in my denominator. Now I left it like that because notice the 3 and the 6 will simplify, and I don't want to mess that up. That's how you get 2 in the numerator and 13 left all by itself in the denominator. Okay, same rules apply for the rest of those, and that's what happens over here on number 4. Now, I did for this one leave tangent of theta alone because I wanted to work that one out with you. So here we go. I've got tangent. Oh, why does it do that? Zoom in. That'll fix it. So we have 10 over 10 root 3. And there's a very obvious canceling of 10 here, so that's what's going to happen. And now I'm left with 1 over the square root of 3. Again, I cannot have the radical in the denominator, so that's where I multiply the top and the bottom by the square root of 3. And I get the square root of 3 over 3 as my final answer. Now, hopefully when you were doing this triangle in particular, you noticed a pattern. And this is a pattern that we actually learned yesterday. Let's take a look at the sides of the triangle. We have 10, 10 root 3, and 20, which for the sake of our pattern, I'm going to rewrite as 2 times 10. Okay. Hopefully you've noticed it. If you haven't, this is a 30, 60, 90 triangle. Okay, because the 30, 60, 90 triangle operates off of n root 3 and 2n. 10 is our n. Here's n root 3, and this is 2n. All the patterns of the 30, 60, 90 triangle. Now, the neat thing about applying trig to a 30, 60, 90 triangle is that it will always end up with these specific ratios. Okay? These 6 ratios for theta and alpha will come back. They come back a lot in what is known as a unit circle. The unit circle is a really big deal moving forward into pre-cal and to calculus. So keep an eye out for these. They will come back. We're not going to spend too much on them right now, but they will come back with a vengeance in pre-cal. For the meantime, though, let's keep going. All right, calculators. I knew y'all wanted calculators, so here we go. Again, your three options are the TI-84, the TI-30, or the Desmos calculator. If you're using Desmos, that's totally fine. I'll do my best to verbally describe what you should be seeing, but I can't do Desmos in this video, so I'm going to use my TI-30. Now, the calculator has trig functions built into them. You're going to want either scientific or graphic for these. So on Desmos, just do scientific. That's the easiest one to deal with. Fewer buttons. Now, the calculator will recognize two different units for trig. It'll recognize degrees. Why does it do that? I don't want that big. There we go. Here we go. Degrees or radians. Okay? These are the two big ones. Now, for the most part, we are only going to be using degrees. You're going to want to check your calculator. So if you're using a TI-83 or a TI-84, you're going to want to go to mode. Click mode. There should be a drop-down menu of all sorts of stuff. One of these options will be radians or degrees. Make sure the cursor is on degrees. For the TI-30, it's a little more difficult to make sure you're in degrees, but it should say something over here. If it says rad right there, we have to fix it. What you're going to do is you're going to click this button right here. You'll get a drop-down menu or across the screen menu, DEG, rad, and then GRD. Make sure you click degrees. For Desmos, there's a button on like the bottom of the screen right here. Make sure that you have degrees showing. Okay? If ever your calculator gives you funny answers, you're probably in the wrong units. So if ever, like for example, you get a negative angle, you're in the wrong unit, make sure you switch over to degrees. That will affect everything. All right, now the trig functions for the triangles, or for the calculators, are all right here. Okay, there they are on the TI-84. This is the TI-83, but they're in the same spot. And then here they are for the TI-30. Now you'll notice above the trig buttons, you have this little sign with a -1. We'll deal with that one in the next lesson. Okay, but for right now, I want you to get a practice with the calculator. I'll do the first two with you so that you can practice and make sure we have the right answers and that you're in the right units. So for the first one, you're literally just going to hit sign and type in 30. You should get 0.5. Okay, or 1/2. Either one. For cosine of 30, you're going to get this weird thing, 0.8660. And here's my next point. The instructions say round to the nearest hundredth. I want you to round to the 4th decimal place. Reason being is the more decimals you have, the more accurate your number is. And we want to make sure that our numbers are as accurate as possible. Okay, last one that I'll do with you is tangent. So tangent of 30, and you have 0.5773. Okay? Go for it. Do the rest. interrupt your independent time to check answers. Now, as you were going through this, you might have noticed that all of these numbers are less than 1. This is good. You should have all numbers less than 1, with the exception of 2. 7 and 10. This is because when you graph tangent is weird. It just is. Sine and cosine have a very similar graph. So if you were to put this on a xy coordinate plane, sine and cosine are going to look similar. Tangent is the oddball out. It decides it wants to do other things. And that's why these numbers are different. Okay? It does make a lot of sense once you know the graph. I'll show you the graph when I get back. But so far, here are your answers. Now, I may have lied to you earlier when I said we were going to get to the -1 later. Now is later. So here we go. This notation is called inverse. So you read this as the inverse of sine 0.5. Or the inverse of sine of a half. The inverse of cosine of 0.5. To get to the inverse, on Desmos, you're going to have to click the functions button. Okay, so screen over here, you have like a drop-down menu of sorts. There should be a button that says function or something to that effect. It'll give you a drop-down menu, and your inverse functions are in this drop-down menu over here. Play around with it. Those are bad verbal instructions, but you do have to click a few buttons. It's not as obvious. With the TI-84 and the TI-83, you're going to hit this second button first. That acts as kind of a shift key, and it puts you to the top of the buttons. And that's how you're going to activate the inverse, cosine, sine, and tangent. Now, the purpose of the inverse is to help you find the angle. One more time. The purpose of the inverse trig function is to help you find the angle. Trig, the original trig function, is a way to find the side lengths. Inverse is a way to find the angle. And that is the sole topic of day 2. But for right now, since we're doing calculator skills, let's play around with just finding it. So I'm going to do the inverse of sine of 0.5. And you should get 30. Now these are all angle measures. Inverse of cosine while I'm talking. So they're going to be nice, neat numbers. Okay? These in particular, as you notice, 30, 60, are even nicer. Remember, when you have angles, angles can be decimals too. Be nice. If ever you get a negative angle, though, something went horribly wrong, you're probably in radians. So go back and fix that. All right, do the others. And here are the rest of the answers. How'd you do? Notice 14. Sine of 2 is an error. Sine and cosine both will only ever go up to 1. Neither one of them will ever go past 1. That was my point earlier when I mentioned that all of the blue numbers are less than 1. Only tangent's a special one. It goes above 1. So if ever you're doing this and you plug in, you get an error, that means that the measure has gone above 1, and that's not allowed. If you're sitting there wondering why, well, that is a question for Algebra 2. More like pre-cal. But this will come back. You will spend a lot on trig. Trig is one of the whack-a-moles of math. It just does not go away. And I'll also spend some more time on it when I get back in class. All right, last page of the video, and I'm only going to do the first 2 problems with you. We have now finally got to the climax of this video where we are solving for the sides. All of that was prep. Here we go for solving. So when you're doing things, first off, you're going to set up your ratio. The way you pick your ratio is based on the information given to you. So let's do this first problem. In this first problem, I have the opposite side and the hypotenuse. Well, that's sine. Sine is opposite over hypotenuse. So the first thing I'm going to do is set up my general equations. So sine of theta is equal to opposite over hypotenuse. Yay! Now I'm just going to plug in. theta is my angle, so the sine of 35 is equal to 15 is my opposite side. My hypotenuse is x. And now it just comes down to solving for x. So when you're solving for x, in order to get anything out of the denominator, you have to multiply by the denominator. So I'm going to change colors. So I'm going to multiply this side by x and this side by x to get it out of the denominator. That cancels, and I'm left with x times sine of 35 is equal to 15. Well, I'm trying to solve for x. I need to get x by itself. So now, since I have x times sine, I'm going to divide by sine of 35. Now pay attention to what's happening here. Notice the sine of 35 travels together. Nothing separates the sine and the angle. All right, the sine of 35 will always travel together. Addition, subtraction, division, multiplication, none of that will ever separate sine and 35. The only thing that will separate sine and 35 is the inverse, which is day 2's topic. So for today, just make sure that if ever you multiply or divide, you take sine and the 35, or sine and the angle together. Cosine and the angle together. They move together. Now this, where I stopped, this is called calculator ready. On tests and quizzes, I might ask you to leave something in calculator ready form. This is what I'm asking for. X is equal to an expression. This is the expression that I'm plugging into my calculator. Okay? So make sure that you're aware of that. Always leave your calculator ready. That's this whole show work bit. Always leave your calculator ready form on your paper. That way I know where you started from. But otherwise, I'm going to plug this in the calculator. 15 divided by sine of 35. And you should get 26.15. Now for our final answer, you can round to the 100th place. But within your work, keep the numbers to the 4th decimal place. So one more time. While you're working, work with the 4 decimal places. When you're not working, you can go to the 100th place because it's an easier decimal to handle. Okay, let's do number 2, and then you're off on your own. So number 2, I have the opposite and the adjacent side, which means this is going to be tangent. So I've got tangent of theta is equal to opposite over adjacent. Plug everything in. Tangent of 40 is equal to x over 12. Again, I need to get x by itself, so I'm going to multiply by my denominator. Times 12 times 12. 12 times tangent of 40 is equal to x. This is my calculator ready form. Because I can plug this into the calculator, which I'm going to do. Okay? Your answer should be 10.06. That's all I got. Go ahead, continue the packet. Make sure you have everything filled in. The rest of day 1 stuff is your homework. Have a good one, guys. I'll see you next time.